Right, I've got the M1 paper for the international papers, January 2019. Question 2 is a vectors question. So we got time t equals 0. A bird A leaves its nest, is located at a point with position vector that, and flies with constant velocity that. At the same time, a second bird leaves its nest, which is located at a point with position vector that, flies with constant velocity that. We don't know what that is because in terms of p. Since time t equals 4 seconds, the bird B is southwest of bird A. We're going to have to do two things. For 3 marks, find a bearing of A that is going on, and for 10 marks, find the speed of B. There we go. Draw a little picture so you can see what's going on. The position vector, the initial position vector of A is down here. It says 20i minus 17j. So it's 20i minus 17j. And it's got that constant velocity, so it's got a negative horizontal one and a positive vertical one, so it's going up to the left. And then bird B has got initial position vector minus 8i plus 9j, so minus 8 plus 9, so it's about there. And it's got that constant velocity, so the j component we just know is twice what the I component is. So it might look like this, or it might look like this, which actually it does. We just don't know yet. And it says time t is equal to 4, the bird B is southwest. So first of all, we're going to find the direction of motion of A. If I draw a little diagram for A, it's 6 and 7 here. So 6i plus 7j. I want the bearing though, so it's that angle I want. So I'm just going to do 360, take away that angle, and that angle is tan to the minus 1 of 6 over 7. Still out the calculator, get 390 degrees. And then we want the speed of B. Now, what it tells us is after 4 seconds, bird B is southwest of bird A. So what I'm going to do, I'm going to find out where they are after 4 seconds and find the vector that joins them up, that takes us from A to B. So A is going to be up here somewhere, because it's gone 4 of those. Because after 4 seconds, each second it does this. So 1, 2, 3, 4, and then bird B is well, it's southwest of A, so it's been down here somewhere. So I'm going to draw it there. So 1, 2, 3, 4. And what I'm going to do, I'm going to find out what this vector is, because I know if B is going to be southwest of A, this must be sort of in the form such that the I component is the same as the J component, because it's sort of going down below the horizontal at 45 degrees. So it might be minus 5I, minus 5J or something, I don't know. Right, so when t is equal to 4, I can work out the position vector of A, because it's initially at 20 minus 17. It's velocity vector with minus 6, 7. So that's what it does every second. So after 4 seconds, the position vector is going to be this. It's going to be O to A plus 4 of the velocity vectors. And then when I work that out, I get minus 4 and 11. And then O to B, same thing again. The initial position vector, and then plus 4 lots of the velocity vector. I'll put that into one vector, I get this. Like this vector that I want, A to B. To get A to B, I do O to B minus O to A. So the O to B minus the O to A. And I simplify that. I get minus 4 plus 4p and minus 2 plus 8p. And like I say, this is going down an angle of 45 degrees horizontal. So these two components must be the same. I can write minus 4 plus 4p minus 2 plus 8p. If I solve that, I get p is equal to minus a half. I can put that into here for the velocity vector, or this for the velocity vector for V. So that's the velocity of B as a vector. And it wants to speed those, so I need to do Pythagoras on that. Find the magnitude of the vector, and it is root 5 over 2, or 1.1 meter per second.